This is the last video tutorial from our dashboard for Java Swing series. So far we have built the dashboard that you can see on your screen. It contains two spreadsheets and a tree map diagram. When we click on a cell in the left spreadsheet, the data in the right one changes and the tree map is updated with the new data. Our aim is to build this dashboard. We have to implement only the bar chart. Let's start. We add a new class variable of type bar chart called chart. Then we initialize it to a new instance of the bar chart control. The constructor requires as a parameter the type of chart. Ours will be overlay. Let's check the online documentation for the JPack controls suite. Here are the members of the bar chart class. As you see, there are a lot of set methods, which let us fine-tune the chart. We will use a few of them for our bar chart as well. First, we set the bar space ratio. This is a double number that tells what is the ratio between the bar width and the space between each two adjacent bars. Then we set horizontal bars to true, which means the chart will be drawn horizontal. Next, we show the scale at the x-axis but hide it at the y-axis. We want to hide the legend title. Legend will be rendered but without a title. We get the legend renderer object, which is responsible for the legend drawing, and set its show title property to true. Then we hide the titles at the axes. We get the axis object with the get x-axis and get y-axis respectively, and use set title to actually remove the axes titles. Here is our XML data file. We will create a custom chart series that will provide us with the labels and data that we need. We can use some of the predefined series of the chart library, but we want to use our own class that does exactly what we want. So, we create a new class called YLabelSeries and make it implement the series interface. The required methods are auto-generated. Our series will use two lists, one with data and the other with labels. the constructor will require that those lists are provided. We add those two lists as class variables in our custom series class. We assign them to the lists given by the user in the constructor. Then, in the getData method, we are supposed to return the data that corresponds to the provided index. We return the value from the data list. In the getLabel method, we must return the label to be rendered at the provided index, according to the label kind. The label kinds enumeration specifies all types of labels that can be rendered on charts. It allows bitwise combination of the members. So, in our getLabel method, we check if we are asked for the y-axis label. If so, we return a label from the label list. If we are asked about the tooltip, we return a string representation of the corresponding data value. We leave the next methods as they are and go to getSize. Here, the size of the series is the size of the data array. For the title of the series, we can return directly a string that explains what this series is about. In getSupportedLabels, we specify what kind of labels this series supports. Here we return y-axis label and tooltip, those types that we handle in the getLabel method. The other methods remain unchanged, and our custom series implementation is ready. Let's add the chart now to the content pane of the main window. Since the layout is a grid and the first 3 cells are already taken, the chart will be put in the right bottom corner of the grid, which is exactly what we want. We add now 2 lists with double values and 1 with strings to the assigned data method. There we will store the data that is parsed from the XML file. We will use those lists later when we create the series for the chart. Now, with each interaction in the cycle that parses the data, we add the values to our arrays. Let's create now two series. One is an instance of our custom series class YLabelSeries. It takes as parameters two of the data lists, one with numbers and the labels. The other series is an instance of the bar series class. This is a standard class that is included in the chart library. It is meant to be used with bar charts and accepts data and labels, inner and top labels. Since we will draw only one row of labels at the y-axis, one instance of the YLabelSeries class is enough. Let's also add a title to the second series, because the title will be rendered in the legend. Now we create a list with the two series and assign it as a series collection to our bar chart. We can run our application now to see what we have done so far. Here is the chart. It is ugly but renders the correct data. Let's add some styling to it. The first thing to do is to add a grid. The grid will be vertical because the chart is with horizontal bars. Then we set the color of the grid lines and their dash style. Those properties are set through the theme object. The theme class is a class with many properties for customizing the appearance of charts. The properties are accessed through the getTheme method, which every type of chart exposes. Here you can see the Common Series Fills property, which specifies a list with brushes to be applied on each series. Each bar series takes one brush from the Common Fills. That's exactly what we need, and we use the Common Series Fills and Strokes properties to apply coloring to our bar chart. If we run the application, now we can see that the chart looks much better. What is left to implement is to update of the chart data when the tree map diagram is updated. For that to work, we only need to repeat the chart code that we added in assign data in the onChange event handler that was raised when the user selects a new cell from the left spreadsheet. This code can be extracted into a separate method, but the convenience here is that the data is parsed and prepared in the onChange method anyway, so we can readily use it. Now let's run the sample. We see that the chart gets updated when we hover over it. So we need to force the chart to repaint itself, which it obviously does not do when we change the series. We call repaint and run again the sample. Yes, now the chart gets updated on cell click. That's great. So we've done building our dashboard in JavaSwing. Thank you for watching, and thank you for your interest in MindFusion Developer Tools.